Hello everyone, this is Lakshmi Ganesh Bhavaraju. I welcome you all to our YouTube channel VectorX Academy. So we started a series called The Titan for JEE Advanced 2026 and Olympiad. This series is especially meant for the students who are aiming for top ranks in JEE Advanced and JEE Mains and Olympiads. So we'll try to cover the concepts in very depth, the important concepts in very depth by solving questions. So this will be your question bank for JEE Advanced, practice bank for your JEE Advanced. So let's start with some very good questions of kinematics, the first mechanics chapter. The questions I have taken might be simple, but the concepts I'm gonna apply are a little tricky. And I'm gonna even use some tricks that you have never seen. At the same time, in the upcoming videos, I'm gonna increase the level of the question slowly. So now let's see this particular question. Okay. Now the question number one, I want it to be simple. Let's do a simple question. So they said find the velocity of the particle at x is equal to 2 minus root 2 and they have given you a xt graph. And then by observing, okay, by observing this particular question, you should be able to say this is a semicircle, right? First of all, to solve any question on what do we say, this particular graphs, we need to have the equation of graph. So let's say the center of the circle here is 2 comma 0, of course, right? Now, how to write the equation of this particular, what do we say, circle? Let's say this is x1, x2, and let's say at any particular point x comma y, or x is here t and y is here x. So x1 minus x2 t minus 2 whole square plus x minus 0 whole square is equal to radius square, that is 4. Radius is 2 mentioned already. Okay sir, understood. Now I want the velocity. It means that you need to differentiate x with respect to time. So let's differentiate the entire equation with respect to time. So 2x into dx by dt is equal plus 2 times of t minus 2. The differentiation of constant is 0. Okay sir. Now dx by dt, I can cancel 2 here. Dx by dt, if it goes that side, it will be 2 minus t by x. So have the value of x. Do I have the value of time here to find the velocity? No. For that, what I'm gonna do? I'm gonna use, see, here many students will come till here, but they'll miss the basic concept that I have seen in many of my students, that they miss the basic concept of how to get x, how to utilize the equation, how to get t when x is given. So just substitute the value of x in the given equation, right? So how will you get? They have mentioned that t is equal to t minus root 2, not x is equal to t minus root 2. Got the point? You can do anyways. There is no issue. For the easy, I'm gonna take this particular part. Now, 2 minus root 2 minus 2, that is nothing but minus root 2. So applying t is equal to 2 minus root 2 at this particular equation. Let's say this equation number 1. So 2 minus root 2 minus 2 is minus root 2 whole square is 2 plus x square is equal to 4. So x is equal to root 2. You may say plus or minus root 2. Don't speak such kind of nonsense here, because minus root 2 is not mentioned in the graph. So now substitute 2 minus root 2, that is root 2 by root 2. That velocity at 2 minus root 2 becomes 1 meter per second. See how beautifully the question is formed. Is this tough? No. Is this easy? No. So it tried to, what do we say, test your multiple concepts. And then options they will give you as 4 by 4 pi into 2 plus root 2. So such complicate options to just freak you out. But the concept is this simple. I hope you guys understood. Let's go for the next question. Yeah. So let's increase the level. This is my favorite book again, Erodo. So this is Erodo 1.42. So let's read the question first. What is the question? A particle moves along the plane trajectory y is equal y of x with velocity v whose modulus is constant. Okay, they're saying velocity is constant indirectly. Find the acceleration of particle at x is equal to 0 and the curvature of the trajectory at that point if the trajectory has the form. So very important. Now here to understand they have asked you the radius of curvature and then acceleration. And then they have given you the velocity to be constant. So how to find it, sir? What is the formula connected to this acceleration and the radius of curvature? A is nothing but v square by rc. Now, let me explain you the concept. Let's take any shape. Let's take, suppose in this case they said it's a parabola. Let's take parabola and then x is equal to 0 at this particular point. Let's say the radius of curvature is like this and velocity is v0 in this direction. The acceleration will always act perpendicular towards the center. Very important point. Okay, so now you understood acceleration. Now, what is the formula for radius of curvature for any body? Radius of curvature is nothing but 1 plus dy by dx whole square whole power 3 by 2 by d square y by dx square. Now, you have got the very important points. Okay, now let's solve. They have given two particular things. One they have given as parabola, one they have given as ellipse. So let's solve the A part of this particular question. Let's draw a parabola, okay, of any particular thing. Let's say the parabola is like this. Okay, that's why y is equal to, they are mentioned as ax square or kx square, where a and b are constant, they are mentioned. So this is at the center, right? They said at the point x is equal to 0. This is the point at x is equal to 0. Now the radius of curvature will be somewhat how? Let's say the radius of curvature I have mentioned is somewhere like this. Let's say this is radius of curvature. Now the acceleration will be like this. So they have asked you both. Now how to find the radius of curvature? 1 plus dy by dx whole square. So y is equal to ax square. So if you do dy by dx, that is nothing but 2ax. Again if you differentiate, you get d square y by dx square, that to be 2a. I hope this is clear. So they said at x is equal to 0. So dy by dx at x is equal to 0 is 0. Whole power 3 by 2 is same. 1 whole power 3 by 2 is 1 only. By, yes, 2a. That is nothing but d square y by dx square. So now you got radius of curvature as 1 by 2a. Now what is acceleration? They have mentioned the velocity to be v. Right, if I'm not wrong. So acceleration at this particular point, as I mentioned, will be in this direction. So if it's v, the center, towards the center, the acceleration will be like this. So that is v square by rc. That is nothing but rc is again 1 by 2a. That is 1 by 2a. Again, if you take, what is this condition beta? 2av. This is acceleration. Don't confuse between this AC and this 2a. This a. These both are different. Okay. So this is one beautiful question. Now the toughest part comes. I don't know whether this particular part may come in advanced or not, but let's cover it. I want you all to know what is the radius of curvature of ellipse at different vertices. This is very important. If you keep on deriving this using our formula, yeah, you'll get it. That is the basic formula that is used for everything. But I want you all to remember, because in multiple chapters, in the upcoming chapters, I will deal with geometry a lot. Like all my students last year, that before year, the questions that I bring will include a lot of geometry. And radius of curvature is used in many things. Even I say that the wire is in the form of a ellipse, and then I connect this particular question to magnetism. So you need to remember some basic points of every geometrical shape. Now let's assume. Now let's say there are different points A. Let's say this is B. This is C. Let's say this is D. I know that you all guys know what is major axis, what is minor axis. Now, very important point. If they ask you, find, and my homework, that I'm gonna give you in this particular video is derive. Now I'm gonna say you directly, but your task is to derive. If I keep on deriving, this will become a maths class, not a physics class. So now, as I mentioned, this is one RC and this will be another RC. Now remember, the smallest radius of curvature will lie at the major axis endpoints, the vertices of the major axis endpoints. So that particular time, the radius of curvature at A comma C will be B square by A. And then as you all know, the, what do we say? This particular acceleration will be again in this direction. Here this will be in this direction. Here this will be in this direction. Here this will be in this direction. Now I forgot to mention something in the previous question, that you need to mention direction also. Okay, you have grown up. It's not your 10th just to, what do we say, mention the magnitude. That is positive j cap. Now here let's see what I can do, beta. Let's see that again. I already said you at A comma C, this is B square by A. Let's solve a radius of curvature at which particular point? B comma D. Right. That particular point, that will be more, that we say it as A square B. How did we get, sir? So I tell you all to solve this by yourself. If it's not possible by you, I'll take this in next class. So just comment out. Okay. Got it. Now, it's simple. Acceleration at particular A is nothing but V square. It's like constant. Let's say this is V everywhere. So V square by radius of curvature, that is B square by A, that is minus I cap. And acceleration of C is nothing but same, V square by B square by A, that is plus I cap. Now acceleration at point B becomes, again, what is that? V square by A square by B, that is positive j cap. And acceleration at point D again becomes V square by A square by B. This is minus j cap. This is again A square by B plus j cap. I hope you got right. So what is the important thing that you need to understand in this particular question? This radius of curvature will be used very much even in the upcoming questions called circular motion. Upcoming questions of circular motion. Now, it's very important for everyone to remember the radius of curvature of any shape if they have given you the equation. Okay. Now, they may ask you, right, what is the radius of curvature at A? If this is A, what you will say? The radius of curvature, that becomes x is equal to, what is this particular one? A comma 0. This will become 0 comma B. This becomes minus A comma 0. If you do this particular equation, if you substitute the values at x is equal to A, which comes the one vertex, you will get the various values. B square by A square by B, which is quite simple. So I want you all to remember this particular question, which is very important. And I'm expecting this type of question to come in upcoming JEE Advanced. This is not tough, but this type of questions are majorly avoided by most of the aspirants. I hope it's clear. Now this is another basic question that may come in JEE Mains or JEE Advanced, everything. I just want you to, what do we say, don't miss it. So I'll say it as sure short question that every aspirant should be able to solve it. If you are not solving it, it means that you are not doing sufficient amount of practice. For this video, let me solve it for you. So now find the total distance covered by the particle. What is average velocity? Again, so they have given you v is equal to v naught into e power minus kt, which is constant, and let's say at t is equal to 0, x is equal to 0. This question will be mentioned. Okay, this particular condition will be mentioned in the question only. Now v is equal to dx by dt. Now that tends to be v naught into e power minus kt. Simple, right? So dx is equal to v naught into e power minus kt times of dt. Now you all know how to do this. Just integrate between the limit 0 to x. At x is equal to 0, I said dt is 0. At x is equal to x, let's say the time is t. Now dx will become x minus 0 is x. V naught e power minus kt is minus e power minus kt by k. Now you need to apply the limit 0 to t. Now if you do that beta, what you will get the equation of x? You will get the equation of x to be v naught by k into 1 minus e power minus kt. This is very much, what do we say, important. This is known as something you will understand in the upcoming chapters. This particular equation is even used in fluids. They will say something called terminal velocity. This particular viscous force comes into the point, viscous coefficient. Even you can use this in air drag questions. So this is very important equations. Okay, this is a very important equation. Now you got x is equal to v naught by k into 1 minus e power minus kt. You find the total distance covered by the particle. Now, what is average velocity beta? That is total distance by time. So the average velocity becomes v naught by kt into 1 minus e power minus kt. This may come in JEE mains. Okay, I'm not saying this question will come in JEE Advanced. This question may come in JEE mains. Now, what will be, what do we say? If I further consider, I'm saying find the velocity or find the distance at t tends to infinity. At t tends to infinity, velocity becomes zero. That is very important point. So what are you able to understand from this? You should understand that as time tends to infinity, the velocity of the particle is tending to be zero. Got this particular point? Very important. Remember. Now, what is the x when t tends to infinity? 1 minus e power minus kt tends to 0. E power minus kt tends to 0. At t is tends to infinity because e power minus infinity is 0. And then x becomes constant v naught by k. So what is the important prediction that you need to understand is that even at infinite time, the particle is traveling infinitely but it's covering a constant distance. Tough to understand geometrically or tough to understand in real situation, but this is what the final conclusion you need to bring out. So if you start learning things from now, like how to draw the conclusion, this is just an equation. What you do, if they ask you the question at t tends to infinity, what is the velocity, or else if they tell you to ask, if they ask you what is the terminal velocity, then you will do this. But if I give you an option such that at t tends to infinity, or else I'll say that the particle is traveling infinite time even though it's covering a constant distance. I'll give it as a statement type while I'm giving this question. Then majority of the students will fail again. So this is how you need to bring the conclusions. Now, let's come to the last point. Last question for this particular, what do we say, chapter or for this particular video. Now, this is a very famous question again taken from my favorite book, Irodo. In the upcoming questions, I'll bring questions from Pathfinder and Croto also. There is this misconceptions that students think Irodo is so tough, Pathfinder is very tough. No. If you have proper clarity and if you know what kind of questions you need to do, the books are very useful. Now let's see. From point A located on a highway, one has to get by a car as soon as possible. B located in a distance L from the highway. It is known that the car moves in the field eta times slower than the way. At what distance from the point D one must turn off the highway? Let's they are saying AD. So they are saying at what distance from way they need to turn down. Let's say this is the particular distance. Let's say the distance is constant D, and they're asking you to find at what distance it need to turn down, at what value it need to turn down. That's it, right? So how to do this question, you know pretty well. You say the time at minimum time, right? Time slower than on the way, and then they ask you to find the minimum time, that will be dt by dx is equal to 0. Now I'm gonna derive a very important, what do we say, thing which you have never used in your life, that I say it as Snell's law in kinematics. What is that? I say it as Snell's law in kinematics. What is Snell's law in kinematics? Pretty important. This is what, see, that question is available everywhere. That's why I'm not gonna do the traditional approach. I'm gonna give you some important concept that you can really apply. So you know what is Snell's law? Now, in light you have studied it. Now let's derive it. Okay, in how we can use it in kinematics. Now let's say this is medium 1, that is v1. In medium 2 the speed is v2, as they are saying, right? Now let's say at some point A, what you know, the light turns like this. Okay, the light enters like this and then it deviates. Okay, now let's assume that it is at a distance of x naught. Let's assume that it is at a distance of y naught. Now, let's say the total distance is L. Let's say this total distance, like let's say this total distance is L. Okay. Now this particular point becomes X. Let's say this, assume this as X. So this becomes L minus X. Now what you know? What is the another important aspect in Snell's law? The theta. Let's say this is theta. Let's say this is theta 1. So automatically this is theta 1. This will be, what do we say? If this is theta 2, this will be theta 2. Okay. Now, what do you know? The light wants to travel in this way, right? Now let the particle, let's say it travels in this way. What do you know? T is equal to T1 plus T2. What is T1 beta? This is nothing but, let's say distance here. That is root of x naught square plus x square. Let's say the velocity here is V1. The velocity here is V2. We have already mentioned. So that is nothing but root of x naught square plus x square by V1 by plus root of here what it becomes y naught square plus L minus x whole square root of, right, root of L minus x whole square. So this becomes y naught square plus L minus x times of whole square by V2. Now this is t. Now we know that for minimum time dt by dx is equal to 0. What does this simplify if you know differentiation well? A majority of the students who are watching this video might be droppers or JEE like 2026 aspirants. If class 11 students are watching, so don't worry, you will learn all these things, you will get in a hand by the next year. Just try to understand the concept. So that will be 1 by 2 root of x naught square plus x square and times of 2x. You may ask, sir, this is also x. No, this is a constant x naught. This is not x. So don't forget. So is equal to 0. If I turn that side, this becomes minus 1 by 2 root times of, and here you have v1, right? 1 by 2 root times of y naught square plus L minus x whole square into minus 2 times of L minus x, that is 2 times of L minus x, and then here you have v2, right beta? Now observe carefully, here 2 also gets cancelled. X by root of x naught square plus x square, that is sine theta 1, right? So sine theta 1 by v1, again L minus x by this particular hypotenuse, that is nothing but sine theta 2. So what is the final conclusion that you are able to derive? That's nothing but you are able to say sine theta 1 by v1 is equal to sine theta 2 by v2. Now how to apply this particular question in our given area? It says that, let's say, what exactly is mentioned in the question? If you understand, you'll understand that initial it's like this and then it is like this and then it has come here and they're asking you to find this particular distance x. If I'm not wrong, right? Now what? Let's draw this line here. Exactly we'll say that this is 90 degrees. So this is 90 degrees. So this will be theta, this will be theta. And they have mentioned that the constant distance is L. The constant distance is L. Right. Now what do you know? Sine theta, that is sine 90, 1 by V1, that is V naught. In the question they mentioned, what did they mention in the question? It knows that the car moves in the field eta times slower than on the highway. Let's say, what do we say? Eta times slower. So how to say? So let's say the speed is V1 in the highway. It becomes eta times slower than on the highway. That is eta times of V1, V2 is equal to eta times of V1. If I'm not wrong, right? So here what it becomes 1 by V naught, let's say that is V naught is equal to sine theta by eta times of V naught, right? V naught get cancelled. You came to a conclusion that sine theta is equal to eta, right? Now what is sine theta? That is x by root of this particular one, that is L square plus x square, that is eta. Now what you will do? Share this. X square is equal to eta square into L square plus eta square into x square. So if you take this, x square times of 1 minus eta square is equal to eta square L square. So now x square is equal to n square L square by 1 minus eta square. Now what can I do further? If I'm not wrong, if I'm not wrong, this is the value of x. Now what you can do, divide the entire equation by e square. So you'll get what? N square gets cancelled, 1 by eta square minus becomes 1. So x is equal to L by root 1 minus eta square. What is 1 minus eta square? We know that. Let's say V1, V2 is equal to eta times of V1. So eta is equal to V2 by V1. So 1 by eta square becomes what beta? V2 by V1. So this becomes V1 by V2 whole square minus 1. This is what you need to remember. I hope, like, if you are really aiming for top 100 ranks, it's very much obligatory that you should remember this. If you practice this in several times, you can get this. Now, so for any question, you can just do this particular way, Snell's law in kinematics. So I think you learned something new and try to apply it. So these are the questions for this video. If you really like what I thought, please do like, share and subscribe. In the upcoming video, we are going to discuss something which is still tougher and very useful. It's much more tricks. Till then, keep waiting. So again, our series will continue. Every day you're going to have class. So Monday it start with maths, Tuesday chemistry, Wednesday physics, again maths, chemistry, physics, and then Sunday you'll have no class. And again from Monday it will come. So for the students who are regularly following our YouTube channel, will gain a very good, what do we say, edge in the final JEE advanced examination. So that's all for this video. Love you all. Keep loving, keep showing your love, and see you all in the next video.